I woke up eager to work on some files, only to discover that my USB was corrupted. Despite trying to fix it, all my efforts were in vain. I decided to strip it open and examine the intricate components of this crucial device. Though I encountered difficulty opening it, I persevered until success was achieved. Let's unravel the mystery of this tiny yet significant piece of technology. As we examine the USB under the microscope, the first thing that catches my eye is the vibrant green surface. This is the printed circuit board, which serves as the backbone of the USB. The green color comes from a protective layer called the solder mask. Upon closer inspection, we notice the intricate network of gold-colored lines etched onto the surface of the PCB. These lines are the conductive traces, responsible for carrying electrical signals throughout the USB. The gold plating not only enhances conductivity, but also provides durability and corrosion resistance. As we explore further, we observe tiny components mounted onto the PCB. These components, including integrated circuits and microchips, are the brains of the USB, responsible for data storage and transfer. The patterns etched onto the surface of the PCB are also intriguing. These patterns, created during the manufacturing process, determine the routing of the conductive traces and the placement of the components. It's fascinating to see how these intricate designs optimize the USB's performance. Lastly, we notice the small soldered joints connecting the components to the conductive traces. These joints ensure secure electrical connections, allowing the USB to function reliably. In summary, the view through the microscope reveals the inner workings of my USB key. From the green PCB to the gold traces and intricate patterns, it's a testament to the precision engineering behind these seemingly simple devices and a reminder of the complexity hidden within.